This is Notes 6 add-on. If you do not have this picture in your Note 6, you'll just have to draw it. It's problems similar to Homework 6. So if you're working on Homework 6 and need an example of how these problems work, this is the spot for you. First, how many objects are in our sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 items in our sample space. So let's find some probabilities. First, find the probability of being in circle A. Some people accidentally say 1 because there's one thing that's only in circle A, but actually here is circle A right here. So how many things are in circle A? 1, 2, 3, 4. So your probability of being in circle A is 4 out of a total of 10 things, which reduces to 2/5. What's the probability of being in circle B? Circle B is right here, a whole circle. So it's counting the stuff that's just in B and the stuff that's in the overlap. How many things are there total? 1, 2, 3, 4, 5. So your probability of being in B is 5 things out of a total of 10 things in your whole sample space. 5/10, which reduces to 1/2, or 0.5. What does this mean with the little line above it? It means what's the probability of not being in A? The complement of A. That little line above means the complement. Not being in A. So let's see, here's A. What things are not in A? This one, all these are not in A. So what's that probability? 2, 4, 6. There's 6 things that aren't in A out of a total of 10. 6/10, which reduces to 3/5, or 0.6, or 60%. This says, what's the probability of the complement of B? So the probability of not being in circle B. Well, here's circle B. What's not in it? This one, this one, this one, this one, and this one. 5 of them, 5/10, or 1/2. Notice that the probability of B plus the probability of the complement of B, which is 1/2. When I add those up, it adds up to 1. 100% of the things that could happen. If you have not B, a B plus not B, you're going to get 1. What's the probability of being in A or B? A or B means that you could be in circle A, or you could be in circle B, or you could be in the overlap, any of those 3 places. So which ones are in that? Well, here's A, this one's in both, this one's in both, this one's in both, this one's in B. All of these are in either A or B. So how many does that make? 1, 2, 3, 4, 5, 6. 6 out of 10 are in A or B. So anything in this region, anything in here is going to be in A or B, 6/10, which reduces to 3/5. Probability of A and B. Now I'm not saying pick one dot, what's the probability I get A, and then pick B, what's the probability I get both of those in 2 picks. I'm saying what's the probability I pick one dot, and that dot is in both the A and the B circle. So I'm looking for these dots in this overlap region right here. This dot is in both A and B, this dot is in both A and B, and this dot is in both A and B. So there's 3 of them in A and B, 3 out of our total of 10, 3/10, or 30%, or 0.3. This reads, probability of being in A given that you're in B. Okay, so start with the given. I'm given that I'm in B. So given that I'm in circle B, what's the probability that I'm in A? Okay, so given that I'm in B, what that does is it takes out our sample space. It changes our sample space. So given that I'm in B, how many things are in B? 5. So what's the probability that I'm in A given that circle? So I'm just looking inside the B circle. What's the probability that you're in A? Well, these 3 are in A. So that's 3/5, or 0.6, or 60%. Okay, so let's do it the other way. The probability that you're in B given that you're in A. Okay, it's given that we're in circle A. So I'm reducing my sample space. I'm only looking at the stuff that's in A, those 4 dots. So out of those 4 dots, what's the probability that I'm in B? Well, these 3 are in B out of a total of 4. So there's 3 in B given that you're in A. Given that you're in A, there's 4 things in A. So 3/4, or 0.75, or 75%. The probability of the complement of A and B. So the complement of A and B is the stuff that's not in A and B. So first, let's find A and B, right? That's this stuff right here, the stuff that's in both in A and B. So what's not that? Well, not that is all the rest of the stuff that's not in that area. All of those dots. 1, 2, 3, 4, 5, 6, 7. There's 7 out of a total of 10. If you compare that with the probability that we did earlier, the probability that you're in A and B, 3/10, you'll notice that the complement and the probability add up to 1. 7/10 plus 3/10 is 1. 100% of the stuff. Probability of the complement of A or B. So where's A or B, first of all? A or B is anything that's in the A circle, the B circle, or the overlap. So all of this stuff is A or B. So what's the complement of that? What's not in there? Just these 4 dots that are on the outside. So that's 4/10, or 2/5. If you look back to the probability of A or B, that was 3/5. These 2 add to 1, 100% of the stuff that happens. The A or B and the not A or B add up to all the stuff that could happen.